I'm Josh Lawrence, a technical specialist with McElroy Manufacturing. I am back to show you how to download the joint reports using a McElroy Series 3 DataLogger. Then, I'll show you how to analyze one of these reports where we fused 16-inch IPS HDPE pipe. I will use the guidelines from ASTM F2620 to verify that the fusion was done to standard. We're going to start by plugging in the handheld computer with the supplied cable. The computer will bring up a window indicating that the desktop and the handheld are connected. I am using Windows 7. If you have a different version of Windows, your screen will look slightly different. When you plug your handheld into your desktop, it may ask you if you would like to set up or synchronize your devices. We do not want to do either of these, as it may put your email and other files on the handheld computer. We just want to look at the files on the handheld. Once you have chosen Connect Without Setting Up Device, click Browse Contents of your device. Navigate the handheld's files as you would your desktop computer's files. Click My Documents and then Joint Reports. The screen is showing you all of the joint reports on the handheld. Click one of the files to highlight it, then hit Ctrl-A on your keyboard. This highlights all of the files. Hit Ctrl-C to copy them to your clipboard. I will create a new folder on my desktop to save these joint reports. Right-click in this new folder and click Paste. Now we have downloaded the joint reports. It is important to verify that all of the files are there. Once I am certain of this, I will delete the files off the handheld by highlighting all of them and hitting Delete. I can sort the files as I do any other using Windows Explorer. Let's take a look at a joint report. The report consists of 4 blocks. The first is the fusion data. This gives the tracking information such as when the fusion was made, who made it, recommended gauge pressures, and so on. Then we see graphs of the fusion process. The graphs show pressure applied versus time. The second block is the zoom in of the bead up and heat soak. The third block is the zoom in of where the heater was removed and the fusion was made. The fourth and final block shows the graph of the fusion process in its entirety. Let's analyze this joint report. The program has a feature that estimates the location of critical points of the fusion process and automatically generates a zoom in of these sections of the graph. First, we will verify all of our information. It is imperative that the data was entered correctly, as the computer uses some of this information to calculate fusion pressures. Check the date and time, joint number, job number, and machine ID. Make sure the model is correct. And we also need to make sure that the pipe size and dimension ratio were entered correctly. Per ASTM F2620, mid-range of the acceptable interfacial pressures is 75. Our interfacial pressures should be set as follows: 75 for bead, 0 for soak, and 75 for fuse and cool. They will be set like this regardless of the size of the pipe being fused. Check the heater temperature. It should be between 400 and 450 Fahrenheit. And also check the calibration date to make sure that the fusion was made within 1 year of the last DataLogger calibration date. Then we verify that we use the recommended pressures for each part of the fusion process. I'm going to use the Analyze feature to take a closer look at each part of the fusion process. Drag the Analyzer box so that it is out of the way. The slider on the right controls the right red line in the second block. I can drag it with the mouse, and I can use the arrow keys. The slider on the left controls the left red line. The middle graph shows only what is between the 2 red lines. Let's look at the bead up. Slide both sliders so the bead up portion of the graph is the only portion between the 2 red lines. This is the bead up portion of this graph. Notice the analyzer data in the middle of the screen. Once you have set the red lines in the proper places, this data tells you the time information. In this case, it tells us that the bead up was 14.4 seconds. Repeat the process for the soak cycle. This fusion was heated for around 6 minutes and 55 seconds. Per ASTM, The minimum for this size in DR is 6 minutes and 33 seconds. Let's check our heater removal time. Set the first red line where the fusion plot starts jumping and put the second line where the pressure reaches recommended fusion pressure. This tells us the approximate time that it took to pull out the heater and make the fusion. In this case, it took just over 7 seconds. ASTM F2620 specifies a maximum of 20 seconds heater plate removal time for this pipe size in DR, although this time should be kept to a minimum. Finally, let's check the cool time. The minimum for this pipe size in DR is 16 minutes. This fusion was cooled for around 16 minutes and 56 seconds. We can also add to the notes with any additional information we want to record, but be aware, once notes are added, they cannot be erased. We can also print one or many reports at the same time like this. Simply highlight all you want to print and click Open. It is best to store these files in their original format. The file sizes will vary, but in this case, the original size was 4 kilobytes. If we convert it to, say, a PDF, the size is 64 kilobytes. That means that it takes up 16 times as much space on the hard drive. And remember, we will be storing potentially thousands of these joint reports on our hard drive, so it's pretty important to keep the file size as small as possible. And also, converting the joint report to another file type means that we cannot use the analyzer feature. Hopefully this helps you better utilize the DataLogger as part of a comprehensive quality assurance program. Be sure to check out McElroy's many other videos to help with all your fusion needs. Go to www.mcelroy.com/fusion to find additional information including charts and other reference materials.